We're going to start off by talking about the topic of limits. Limits are covered in sections 1.2 and 1.3, and I'm going to combine those two sections. So limits are the things that separate calculus from algebra. There are things that you can do with calculus using limits that you simply cannot do with algebra. So let's consider the following function. F of x equals x squared plus x minus 2 divided by the quantity x minus 1. There are many values you can substitute in for x, but one that you cannot substitute in is x equals 1. Well, very often mathematicians need to know what is happening to this function at points near that discontinuity. And so this is where the idea of limits come in. A limit can tell us how a function behaves near a point that may not be defined. So there are three main ways of evaluating limits. There's the numerical method, the graphical method, and the analytical method. And we're going to talk about them in that order. The numerical method consists of substituting in values close to the forbidden value of x and just observing what happens to the function. So in the example, what we can do is look at values of x close to 1 and then observe the value of f of x. So let's look at this table. Remember that f of x is equal to x squared plus x minus 2, all divided by x minus 1. So let's substitute in some values that are close to 1. Remember, we cannot plug a 1 in. What we can do is substitute in some values close to 1. So what I'm doing is I'm starting here at x equals 0 and letting then x get closer to 1. And then I'm also starting at x equals 2. That's on the other side of 1. So I'm looking at values of x smaller than 1, and I'm looking at values of x larger than 1. So we can start at 2, and then go to 1.1, and then 1.01, and we'll look to see if there's any trend. Well, if we plug 0 into the function, we're going to get the value 2. If we plug in the value 0.9, we're going to get the value 2.9. If we plug in the value 0.99, we're getting 2.99. So I think you can probably see that there is a trend. As our values of x get closer to 1, it looks like our values of f of x, our y values if you want to think of them that way, look like they're getting closer to maybe 3. Well, let's see what's happening from this side. If you plug in 2 for x, well, if you plug in 2 for x, you're going to get 4 plus 2 minus 2 is 4, and then that's divided by 2 minus 1, or 1. That's going to be 4. If you substitute in 1.1 for each value of x, it turns out that you get 3.1. Now, I've already determined these values ahead of time, so as to save a little bit of time. And when you substitute in when you substitute in 1.01, you get a value of 3.01 out of the function. So it looks like what's happening is that as x gets closer to 1, that the y values are getting closer to 3. Now, we still cannot let x be 1 exactly, but if we get really, really close, if we let x get really close to 1, then it seems like maybe our f of x are getting closer to 3. Now, what do I mean by really close? Well, I haven't said exactly what I mean yet. But there does seem to be a pattern here, and maybe you can make this jump that we could make this as close to 3 or this as close to 3 as we wanted by picking x close enough to 1. Let's say we wanted let's say we wanted our y value, our f of x value, to be 3.001. That's quite a bit closer to 3 than 3.01 is. So can you conjecture what it is that you would need to substitute in for x to get a y value of 3.0001? Well, if you guess that it's x equals 1.0001, you're exactly right, and you can check that on your calculator if you want to. But the point is this: we can make f of x or y as close to 3 as we want to by choosing x appropriately, choosing it really close to 1 but not equal to 1, because again, remember, at x equals 1 this function is not defined. Alright, so this is not what's known as the numerical method. Now, it does have some drawbacks. We looked at the value, the closest value of x to 1 that we looked at was 1.0001. Well, how do we know that maybe the following doesn't happen? What if we picked a value of x, say, really, really close to 1, like 20 zeros or so, 2, something really close to 1. Maybe the function goes really crazy when it gets that close to 1, and the values of y, the f of x values, become unpredictable. And there are plenty of functions around that do that. So the numerical method is not really the best choice for evaluating these functions. The limits of these functions, rather. So here is a non-rigorous version of the definition of a limit. This is the definition of the limit of f of x as x approaches c is L. In the example that we just looked at, our conjecture was that the limit as x approaches 1 of x squared plus x minus 2 over x minus 1 is equal to 3. The idea being that the closer x gets to 1, the closer this thing gets to 3. So the limit is this number here. The limit of this function at 1 is 3. What that means is that as x gets closer to 1, the y values get closer to 3. Actually, it means something a little bit more than that. What it really means is we can make this value, this expression, take on a value close to 3. How close? As close as we want. Arbitrarily close, we might say. This expression, x squared plus x minus 2 over x minus 1, can be made arbitrarily close to 3 by choosing x close enough to 1, but not equal to 1. So we're not going to let x go to 1. Does that mean that this function ever reaches 3? Well, maybe or not. It depends on the function, depends on this number here. This function might not ever take on the value 3, but it can be made as close to 3 as we want by choosing x sufficiently close to 1. At least that's what we think. That's our conjecture at the moment. But anyway, let's go back to this definition. So let f be a function that is defined on some open interval containing c, except possibly at c itself. If there is a number L such that f of x can be made arbitrarily close to L by choosing x sufficiently close to c, but not equal to c, then we will say the limit of f of x as x approaches c is L, and we will write that this way. So the L is the general name for the limit. That's what the value of 3 was. X is approaching 1, we usually call that number c.